All right, so we're going to talk about structs and unions in Odin, which are the two main ways, or the two ways you'll define your own data types in Odin. And so structs is a collection of fields and associated values with those fields. It is just a way to, well, structure, pardon the pun, data to be together, right? So it's a bag of fields together. So let's say we have a function or a procedure that's called read configuration. It takes a file name, which is a string, and it returns a configuration. Here, if I save this now, we'll see that this is saying, first of all, we don't have a configuration. Let's fix that part. A configuration is a struct, which we define like this. So configuration : struct, like this. We're going to make this an empty struct for now, and then we're going to say return configuration, like this. If we do Odin run sandbox now, let's see, we're going to find that this now is like this, and there you go. Now we have our configuration here, right? So we are now calling this read configuration function here in our main, and saying that yes, we have a configuration. So this is an empty struct, not super interesting. It's there mostly to, well, be, right? This can be useful. It's not actually as not useful as it seems. But let's put some values in here, right? So let's put a file name, which is a string. Let's put an interval, which is an int, and a, not the timeout URL probably. Not that it matters. We'll have these three. So if I run this now, we'll see I didn't need to add anything, right, to my code. That's because everything in Odin, and everything, really everything, is zero value initialized, right? So if something exists, it can be the zero value, period, right? So for strings, that's the empty string. For int, it's 0. For F32s, floats, and so on, it's 0.0. And so on. For booleans, it's false. And so when we're actually constructing this configuration here, we're simply saying, well, construct it with the zero values, right? And so this here is kind of interesting also, because it's not that when we create values some other way, we're now forced to give all of these values. We can actually say config here, configuration, config, for example, like this, and this will give us exactly the same behavior, right? And there's actually a kind of shorthand here that can actually, in many ways, improve documentation for many functions. So in this particular case, it's fairly obvious we're returning a configuration, so it's maybe not that big a deal. But we could also say config here, which will actually obviate the need for this one here. So if we run this now, we get the exact same behavior, right? In fact, there's a feature in Odin called a naked return, which allows us to do this. And this will give us the same behavior. I wouldn't recommend it. I recommend naming your returns always, right? It can get confusing if you have naked returns all over the place. I would just recommend just saying, hey, you know, let's just have actual, like, we're specific every time, right? But yeah, this is a useful pattern. Naming your return values, that means basically they're going to be stack allocated for you. You don't have to put them in the body of your function, right? They will just exist from the beginning of the function instead. So now we have our configuration here. It is a struct. There's something interesting that happens here, right? Let's say we had a field that was calculated later. So we have this F32 field here. It's not going to be relevant from the beginning. There's some kind of function that might fill this in or something, right? That means there's nothing that forces us to say, hey, I need this value from the beginning. If you used other languages, certain other languages, you might be forced to fill in a value for every field. Zig, for example, works like this, right? So if we were using Zig, we would have to say, hey, I want to return a configuration. The file name has to be file name, the interval has to be 0. I have to just come up with a value. The URL here is this, for example, and calculated later is this, right? So what we're doing here in effect is, well, basically the same thing as in Odin, except kind of worse. We just have to mention these things even though they don't matter. Calculated later is specifically here not the field that actually matters right now, right? So in Odin, because it does not matter, let's say we have interval coming in from outside here. We could just simply say this, right? Or in certain cases, we could just say, hey, config, and then we could say config file name equals file name and interval this, right? This leads to code that talks about the things that are relevant right now. And that's a neat kind of thing, I think. It becomes sort of less chatty. And it's not at the expense of anything necessarily, right? Because you saw in the other cases, when we are forced to give a sort of value for things, well, we kind of just have to come up with some BS value or just give the 0 value, right? So in effect, we're not gaining anything, right? In many cases also, in Zig, for example, at some points, I simply did this, right? Where I would do config dot, for example, URL undefined, right? And so undefined is just a garbage value in Zig. It's the equivalent of this in Odin, except we don't really use it. And so we can't actually use this one in Odin in many places. So undefined here becomes just whatever memory, uninitialized memory exists. In debug mode, it's actually something like cd, 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 cd. And that's for debugging purposes. But this is an interesting thing, right? Being forced to set all fields isn't necessarily the kind of win that you might imagine. It sounds good on paper, but it might not be all that interesting to do, right? I don't know that it actually is a win overall. I certainly have found that code is nicer and clearer without this requirement, to be honest. And so, yeah, I think that's an interesting thing. Let's remove calculated later though, and possibly URL here for the purposes of this, and say that interval could be one of 3 different things, right? So I'm gonna say interval is a type here, right? We're gonna name a new type, and we're gonna make this a tagged union. This is how we talk about values that can be one or the other or something else, right? And so interval here will be a union, and we will have never as a case, and we will have once and every, right? And so this will be a value here. Let's just say every millisecond, like this. And now we have never, once, and every milliseconds. These are the valid values for this, right? And now, of course, as an interval, we have to take an interval here, right? And so we are going to now say, okay, what is never? Well, never doesn't hold any information, right? It's an empty struct, right? Because never, the value of this is in the name itself, right? But we have a struct here to represent that, right? Once, likewise, is an empty struct. And every milliseconds is a struct that takes, let's say, an interval. Like this is an int, right? We could also call this value, whatever we want, really, right? And so here, these are now the 3 different cases we can have for an interval. And this is a useful, let's see, every milliseconds is what we want. There you go. So this is a very useful kind of language feature to use for things that simply can be one. These are for closed sets, right? So we have a set, it can be one of these and no more, right? We don't extend it from some other program and so on and so forth, right? And so for things like payment methods and so on, this can be very useful, right? A payment method can be a bank transfer, it can be a credit card, and so on and so forth, right? Some kind of employee type, perhaps. It's a very useful tool to use. And in other languages, they would call this a sum type and so on. Here's just a tagged union, because the truth is they're not quite the same, right? but they do give a lot of the same benefits. We can basically consider them mostly the same. So how do we actually look at this value and say, you know, I want to know what you are so I can do the right thing based on what's going on, right? So for example, if I wanted to do this, we could do this, switch I in interval, right? Like this. We could say case never. And here we could say FFT printf, for example, never be. And then we could say case once, like this, and every millisecond, there you go. Import format, and there you go. So now we're gonna, there you go. Okay, so. Right. So now we're printing every milliseconds interval 0, right? This because I put a 0 initialized thing here. We could say 42 here. We could also say interval equals 42 like this. And we will see that it says interval 42. And so this is, I think, the primary way to interrogate your tagged unions to see what they are, right? And importantly, if I were to leave out one of these cases, like this, the compiler will tell me, hey, you're not handling every milliseconds, right? That's a big boo-boo. You want to check all of the cases, this seems important, and so on, right? Also, if I were to say case configuration, right, that also is not going to work. That is not part of the tagged union. An interval does not contain that as a possible member, right? And so what's actually going on under the hood here is really that we have a tag type, some kind of tag that says, you know, this is this case, and in that case, we access the data associated with this. You would build this with unions in C as well, except there we can't actually we have to manage our tag types ourselves and so on. That's really the big difference. Here it's all managed by the compiler, and so you get this kind of nice workflow with them, right? And so we saw here that we have exhaustiveness checks and so on. And importantly, this also works with the different features that we saw in switches, right? We can say never or once if we want to check both of these at once. So there's no real downside necessarily to checking all of them, to be honest, right? Because we could just mention the ones that are sort of the throwaway cases in one fell swoop here, right? Then we can handle the very specific ones and so on, right? There's also another way to check for these cases. We can say every, for example, here is every milliseconds, like this. We can say interval dot every milliseconds, like this, exactly like Copilot dot. And what's going to happen here is that this here is going to be in every milliseconds. But that value is only usable if this Boolean value here is true, right? So what we can do, and this is a fairly common, reasonably common pattern, is we can say if, like this, is every. Now we're doing this assignment here, and then we're saying, and the condition for this if is this, right? And inside of here, we have every milliseconds, right? So if I were to execute now, we should see 2 prints about every milliseconds. And we do, right? If I didn't have every milliseconds, right? If we set this to once, like this, we would see never or once, right? And so these are the basics of how we use this struct value, struct values inside of tagged unions, and how we check them to see what they are, right? And there's one important thing here that sort of might not be obvious, right? In other languages, we would usually have to talk about constructors. There would be some kind of wrapper around the type that identifies the case. In some ways, we're managing the tags ourselves, but also it's done via the compiler, via words instead, right? So in Haskell, of course, we would, if we had an interval in Haskell, we would have something like data interval like this. Actually, let's do this. Never, once, and every milliseconds. And here we would have the every milliseconds data, actually, because it's unsafe to have a record here for reasons. Not good reasons, mind you, but for reasons. And so this is how we would have to deal with this, right? And in this particular case here, every milliseconds, it becomes obvious here that we are now wrapping the type itself, the actual payload, in some kind of name, right? Every milliseconds here is a name that identifies this case, right? Whereas if we look at the Odin version of this, every milliseconds here is a type. It's not a name for something. It's a type itself. And this should sort of now already clue some of you in to what we could do, right? So if I say, let's remove every milliseconds here, right? And then we realize that in this particular case, we really have an int, right? And if I save now, of course, it's going to say you're not handling ints. And that's interesting, right? And it's also going to say, you know, every milliseconds doesn't exist. So let's replace here with int, right? And now we can see here, with some very small changes, it still works. That is because we are talking about types. We're talking about payload types, not names of cases, right? We are always only talking about the payload type in Union, in Odin, rather. So Odin tagged unions only talk about, hey, this is the actual payload type, right? And so if I had some other union here, for example, some other union, I could, for example, have I could have never and bool and int, right? So two of these are now overlapping with our different tagged union. And the interesting thing here, right, is that if I copy all of this code, even we can say switch O in other union. We're going to have a other union value like this. Now we can see that, okay, so never was one of these values, right? Let's check for never or bool here. And then int we have here, int there. Here we're checking for int. So now we will very quickly realize here that checking for these values never changes based on what union we're checking, right? We didn't have to use a specific constructor that has to be named uniquely or anything interesting like that, right? We are checking simply for a payload type. That payload type can be, it can exist in many different unions. Odin understands which union you're dealing with, right? It understands that in this particular case here we have some other union, right? And it knows that an int is a case that we can have in that one, right? So talking about constructors here is irrelevant in the grand scheme of things, right? And that's an interesting idea, right? We're doing away with constructors. It's all about the payload types instead. And we're getting a lot of the same benefits, right? And that's very interesting, I think. So yeah, those are the basics of using structs here, right? And tagged unions for talking about, it can be one of these cases, never more than one, etc. And I hope this was informative. I hope that if you do like these videos, I would recommend subscribing and so on, of course. If you have suggestions, feel free to just comment on the videos. I really do like getting the feedback and so on. And we'll try to make these videos better over time. We're going to get into more advanced things, more interesting things over time. very soon, I hope to have all of these kind of basics out of the way, and we can actually get on to projects that are a bit more interesting and so on. But yeah, thank you for watching, and have a good one. Ciao.